My name is Sanjita Prasad and I'm going to teach you chemistry. And the chapter which I am going to teach you today is the periodic table, and I'm going to particularly teach you about the periodic properties. Okay, so let me share the screen with you all. So, as you can see here, periodic table of elements. Okay, now what is the periodic table? It is the classification of elements into groups and rows. As you all can see, no, from 1, 2, 3, 4, 5, 6, 7. How many periods are there? 7 periods. And as you all can see, starting from number 1 till number 18, there are 18 groups. Okay, the horizontal rows, they are called periods, and the vertical columns are called as the groups in the periodic table. Now you can see, earlier there was different notation for numbering the periods: 1A, 2A, then 3B to 7B, then group 8, 1B, 2B, then again 3A, 7A, and then 8A. But according to the IUPAC nomenclature, okay, how do we number the groups nowadays? Starting from 1 to 18. Okay, now you see, in the first group, metals are present. Okay, and moreover, they are known as the alkali metals. Now, why they are known as the alkali metals? It is because they are very much reactive in nature. Okay, and in the group 2, alkaline earth metals are present. Okay, so why are they known as alkaline earth metals? Because they also form alkalis. Okay, but the alkalis formed by them, no, they are not not as strong as the alkalis formed by the group 1 metals. Okay, then you can see transition metals. You can see the color, right? Light orange in color. Now, in the case of transition metals, no, they usually form colored ions, and they have two incomplete outermost cells. Okay, so in that case, then after that you see we have the other metals like aluminium, gallium. Okay, now they are also metals, but they are not as strong as the alkali metals. Okay, then you can see in the purple group, boron, silicon, germanium. Okay, now what are those? They are also called as the metalloids. That means they show the properties of both metals as well as non-metals. Then you can see few non-metals. Okay, so which are the non-metals present out here? You see carbon, nitrogen, phosphorus. Then this group is known as halogen. Then comes the noble gases, which have a stable electronic configuration. Okay, so today what are we going to study? How does the property differs, no, when you move across a period or down the group? Now, atomic size depends upon the number of cells. An increase in the number of cells, of course, will increase the size of an atom. And it also depends upon the nuclear charge. So, what is it? It is the positive charge of the nucleus due to the presence of protons. Okay, and what do the positive charge do? It exerts a nuclear pull on the outermost electrons. Okay, what is it called? It is called as nuclear pull. Okay, yes. Then you see, what is the trend in atomic size? Now, when we move from left to right across a period, what happens? The number of cells remains the same. But what happens? The atomic number also increases, right? So the number of proton also increases. So the nuclear pull increases. So due to the increased nuclear pull, what happens? The atomic size goes on decreasing as we move from left to right across the periodic table. So out here, what do we see is that, okay, so when we are moving from left to right, what is happening to the atomic size? The atomic size goes on decreasing. Okay. Why does it goes on decreasing? Because the number of cells remains the same. Okay. But what increases? The nuclear pull. That is the pull exerted by the nucleus on the outermost electrons. So since the nuclear pull increases, what happens is that the outermost electrons are attracted more towards the nucleus. Okay, so the size goes on decreasing in this way. Okay, you can see. So one thing to remember is that the number of cell remains the same. Okay, but since the atomic number increases when you move from left to right, due to that, what happens? Nuclear pull increases and hence the atomic size goes on decreasing. But when you move down the group, in that case, number of cell increases. In the first group, there are how many cells? First group has only one cell, second group has two cells. Okay, the number of cell goes on increasing. Hence, what happens when we move down the group? Okay, the nuclear pull is not so effective. So, what happens is that the atomic size goes on increasing as we move down the group, the periodic table. Okay, so this is what we see. Now, so you can see due to the successive addition of cell, which is more effective than the increase in nuclear charge, the atomic size goes on increasing as we move down the group. Okay. Now, the size of the atoms of inert gases are bigger than halogens of the same period. Okay. So the size of the inert gases are bigger. Now, who is responsible for this? The outermost cell of inert gases is complete. You know that very well. They have a stable electronic configuration. Okay. So the electron repulses are maximum. Okay. So the effect of nuclear pull over the valence electrons is not seen. Nuclear pull is not at all effective. Okay. Because the atom is already stable. So that is why the size of the atoms of the inert gases are bigger than the halogens of the same period. Okay. Then what do we see? Cations. What are cations? Positively charged ions are known as cations, like Ca2 plus. How are they formed? By the loss of electrons. Okay. So since they are formed due to loss of electrons, the number of protons are more. Okay. Since the number of protons are more, nuclear pull will be more effective. And hence what will happen? The electrons are strongly attracted by the nucleus due to the nuclear pull. And hence what happens to the size? The size decreases. Okay. The size decreases. So sodium ion, the size of sodium ion is smaller than that of sodium. Okay. Then you see anion is larger than the parent atom. Now, how are the anions formed? They are formed by the gain of electrons. For example, chlorine. Atomic number is 17. What is the electronic configuration? 2, 8, and 7. So, how will chlorine become stable? It will become stable if it gains one electron, okay, and forms negatively charged ion. Okay, so what happens is that since the number of electrons are more, the nuclear pull will not be effective. Less inward pull is experienced, and hence the size expands. Okay, then you see the size of isoelectronic ions. Okay, now from the name itself, it is clear isoelectronic. Okay, iso means same. So the ions which have the same number of electrons, like you can see magnesium, then you have sodium, fluoride, oxygen. Okay, so the number of electrons in them is 10. Okay, but protons it differs, right? So since they have the same number of electrons, the greater the nuclear charge, smaller is the size. Okay, whose nuclear charge is the greatest? Magnesium, because it has how many protons? 12 protons. So the electrons are more attracted towards the nucleus. So magnesium ion has the smallest size.